Hello, everyone. Welcome to the sessions of programming in Python. This particular session particularly focuses on the module Pandas. So, in the previous and the preceding classes, we have learned what a module is. It's external libraries that we create and in which we keep the definitions of different functions and classes, and we can always import that particular module and use the functions that are defined in it, right? Uh, so module is something that we ourselves can create, and then there are many of the modules which are already present on the Python central server. Okay, PyP. So we often install it in our server in our system using pip command. You would have observed that while dealing with Python, you would have come across such command pip install, say NumPy, or you would have come across pip install pandas, right? So what is this? Why do we give such command in our command prompt? So if I'm saying pip install pandas, what I'm prompting here to the system is I am asking the pandas library to be installed from the central server. Okay. And since it is already installed in my system, it is going to tell you that the requirement is already satisfied. However, uh, had the pandas library not been already installed in your system, then once you give this command, it will start getting installed. Okay. So how do we get started with pandas? We should always start by importing pandas. Okay. But now you must be wondering, why do we need pandas? What is the whole use of pandas? So in the core Python, you would have learned many data structures, right? Something called as list, in which you are storing the data in this particular format. Sequence type of data stored in a list in a sequential manner, all the elements separated by comma, isn't it? And when it was dictionary, uh, how would you define a dictionary? You would create a flower bracket and you would write a key, say name, Elisa, and age, right? This is how you would create a list. Maybe I can rename it something else, X and Y, right? This is how you would create. So this is nothing but it's a different structure or different style in which you're holding your data together, isn't it? Now, these being a part of core Python, but when it comes to pandas, pandas has introduced to you three more data structures. One is called as series, one is called as data frame, and one is called as panel. To understand that better, let's first recall that if it's a list, then all the elements in a list are stored and they all have a underlying positions or index, right? So this is index 0, this is index 1, this is 2, this is 3, etc. These are positions, isn't it? And a dictionary has keys, right? And the key is mapped to a corresponding value in the core Python, right? Now, when it comes to pandas, you have something called as, let's try to understand what a series is and what a data frame is, okay? I'm pretty sure that you all would have seen a Excel file. Let me create one Excel file for you. So if I'm creating one Excel file here, create a new folder and Excel file here, I'll write here students data, okay? Student data.xlsx. So this is the Excel file that I'm creating. And here you would see that the Excel looks like a tabular structure, isn't it? It has column headers and it has row headers, right? So if I'm writing something like this here, maybe 1, 5, 6, 8, 7, 9, 2, 4, 6. Okay. If I ask you at what position is 7 located, and you would easily tell me that it's at B2, right? B column and second row, B2. So it's easier to locate, right? Now, in a similar structure, our data frame looks like, okay? So our data frame is nothing but it's a tabular like structure. Uh, and it is going to have column headers and it is going to have row headers. Then what is series? Now series is just a single column. So let's try to visualize it better. If I'm writing name here, a name, column name, and I can write here maybe Arun, Aditya, Shikha, Vaibhav, okay, Arjun. All right. This is my row. Oh, sorry, this is my column. Okay, this is my single column. So this, and maybe I can say here, as you can see, by default, the row headers were 2, 3, 4, 5, 6, right? But if I want to give it a better name, maybe I can write here S1. S1 means student one. And in a similar manner, if I write these headers by myself, so you can see that there is a column headers, there are row headers, okay? And then you have data, correct? So it's a single column. A single column like this is called as series. So for a better visualization, let me paste it here. So this is something called as series. This is series, okay? Just like how your list looks like, how your dictionary looks like, a series in Pandas looks like this: a single column with values. Each element or each position is going to have a corresponding row headers and the common column headers, okay? And now this is like a 1D data, okay? This is like a 1D data, a sequential data. But what if it was a 2D data? Okay, now what do you mean by 2D data? Um, if I were to correlate it with the list, I can tell you here that what I just created was something like this. I have Arun, I have Aditya, I have Shikha, and I have Vaibhav, etc. Right? However, this is a list. A list is a 1D data. But what if I had a list of lists? Okay, what do you mean by list of lists? So there are two lists within a larger list. So here I can write maybe scores 5, comma 10, comma 78, comma 95, comma 82. 2, 3, 4, 1, 2, 3, 4. Okay, let me keep just two. Okay, yeah, right. So if I push it down here, so this could be Arun's score, this could be Aditya's score, and this could be Shikha's score, and this could be Vaibhav's score. Point is, you see, end of the day, it is still a list of list, but this list of list could be well interpreted within a as a 2D data, right? In a similar way, it's a 1D data when you say it's series, but if I have multiple columns like age, okay, and I write here 25, 30, 45, 18, and 20, okay, and then I have city, and a city here I write Delhi, Mumbai, Tokyo, London, and then California, okay, something like this. Now this is called as data frame. A data frame has a multiple columns and multiple rows. So this, if I am placing it here, this is called as data frame. All right. Now, what is panel? A panel is nothing but if you have multiple such data frame stacked one above the other, which looks like a 3D data, then it is called as panel. All right. How well, in this particular series, we are only majorly going to focus on two things. One is called as series and other one called as data frame. All right. So this is of our interest and this is majorly used in pandas. Okay. Right. Now, when we are learning, you have gotten the basic idea of what a series is and what a data frame is, right? Now, let's learn how to create a series and how to create a data frame, okay? Remember that these are objects, okay? And if something is an object, then obviously it is going to have attributes, and it is also going to have methods, right? Right. So let me create for some data, initial data like name equal to Aditya, Arjun, Rohit, Pallavi, and Vaibhav. Okay. So here is a list variable in which I have stored these values. Now, if I want to convert into series, now let me write here name underscore s. Okay. So this is just a notation I'm following so that it's clear to us that what it is. So here I'm going to write pandas dot series. And in this, I'm going to pass name, and then thereafter I'm going to print here name underscore s. All right. Let me run it. You can see here that this series has been printed for you, right? So this is what a series looks like. But if you see here, uh, this series has default row headers, isn't it? So if something has a default, and if you want to give your own customized row headers, what you can do is you can pass here uh, another argument. But before I pass the argument, let's try to understand what this whole syntax was. So basically, in the pandas file, I am calling a function. Oh, sorry, I'm calling a class called as series. Okay. And in this, I'm passing some value. So basically, this returns me back a instance of series object. Okay. So here, this is series. It's converting this list into series. Okay. Now, suppose I wanted to uh, if I wanted to give some custom row headers, then I can always provide this index uh, argument with some value, something like S1. Okay, S1 as in student one, then I can write student two, then I can write student three, and I can write student four, and I can write student five, two, three, four, five, right? Okay, good enough. So if I run this, you will see that the row headers have been modified, isn't it? Now, like I said, each object has its own attribute, and each object has its own uh, methods, right? So here, let's see what methods it has. In case this is a series, if I'm printing here the series, then the whole series shall be printed for you, right? Okay. After this, I'm going to print. Let me print here dot shape. Okay. Now, what is this? Shape is a attribute. Just like for any attribute we have many just like for any object we have many attributes, right? So for this series object, one of the attribute is shape. Let's see what shape gives you. It tells you 5. Okay. So this is a tuple with single element. So a tuple with single element is always trailed by comma. Okay. uh, what do you mean by 5? 5 is nothing but how many elements are there. Okay, so there are 1 2 3 4 5 elements, right? Now I'm going to write here size. It again tell you 5. What is the difference between shape and size? It will be more clear when you do the same, you look for the same attribute for the data frame. All right. Okay. Another thing could be if I'm saying name underscore s dot describe. Okay. So what this describe is, now it's a method. Okay. For this series object, I'm calling a method. And you can see that it tells you the count is 5. That means for this particular object, the count is 5, and there are 5 unique values. The top value is Aditya and the frequency is 1, right? So this is how it is giving. Now, what what is it? What I just did? Well, if you're going to have a data with yourself, the very first step we should always be doing is we should analyze the data. Okay, we should look into it, what kind of data it is. All right. What is the size of data, how many counts are there, uh, what kind of data type it is, how many elements it is storing. So these attributes And these methods help you identify that. All right. Okay. Now this is about series. In case you want to know what is the row headers for the series, you can also write name underscore s dot index. Okay. Let's try to print this up. And you can see that this is your row headers. If you want to observe it in a list format, you can always typecast it to list or convert it into list. And you can see here that these are your row headers, isn't it? So that was all about series that we learned, the basics of how to create a series. Okay. Now let's get into data frame. Okay. So suppose I have all right, so you can see here that I created one dictionary. And if I have to convert this dictionary into a data frame, then what I'm going to write here is, let me write here data underscore df. Okay. So data underscore df is a new variable in which I'm going to store the data frame. Now, how do I get a data frame? Again, I'm going to call the pandas library, and I'm going to call another function called as data frame. Remember that it's a series that creates the series for you, and the this method data frame creates the data frame for you. Within this, I'm going to pass this dictionary. Okay. So now if I try to print here data underscore df, you can see here that data frame has been created for you, right? And in this data frame, you can see that you have column headers. All the keys have been converted as a column headers, and these are your row headers. In case you want different row headers, then what you can do is, while you're creating the data frame itself, you can pass index equal to something similar what we have already done. Let me take this from here itself and let me put it here. And since there are just 4 elements, let me remove the S5 here. All right. Okay, if I run this, you will see that the data frame now has a customized row headers and customized columns, right? Okay. So these are two ways how you can create the data frame of series uh, by converting the existing form of data into these. Okay. And if you want to now uh, observe certain attributes of these data frame, you can always go ahead and access those attributes. Something like, what is the shape? What is the shape of this data frame? So it says 4 comma 3, right? That means it's 4 rows and 3 columns. You can see here that there are 4 rows and 3 columns, isn't it? And if I want to write here dot size, you can see here that it says 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 values here, right? So it says 12, isn't it? Now, if I say here data underscore df dot columns, you will see that you'll get all the column names here, right? In a similar way, if you're writing here dot index, you will get all the index values. Make sense? Right. So now, and of course, if I write here data underscore df dot describe, and you will get a quick statistics of your data frame. It tells you that this describe methods gives you a mathematical statistics, a quick statistics, and it is only going to cover your numeric columns, not your string columns. What I mean by numeric columns, so here in this data frame, you can see that there are three columns. One is name, age, and height, and only two happens to be the numeric columns, that is age and height. So here you see that you have the statistics of age column and height columns. You have the data analytics of these two columns. You can see that the count is 4. There are 4 elements in both the column. The mean is 39.5 here, 177.75 here. Standard deviation is this. The minimum value captured is this. The 25% value of is captured is this, 50, 75, and the maximum value captured is this, right? Another quick way to look at the statistics is called as info, okay? This tells you that in the column name, there are 4 filled values and there are no null values. Okay, what do you mean by null values? It's like a empty value, okay? And the type. So these two columns is integer 64 type, this is integer 64, and this is object. It's a string object, right? What you just learned here, it's how to create a series, how to create a data frame from the existing data in the Python environment, okay? And how to take a quick look at the attributes and the methods and the statistics of the data frame or the series that you have created, right? But if you have to create a data frame, it's not always that you will have the data with you already that you can convert. Sometimes you might be getting the data from the server, you might be getting the data from Excel file, you might be getting the data from CSV file or text file, right? So what you might be wanting to do is, before you do the data analytics on any data, you might want to acquire the data, right? So one of the way to acquire the data in Pandas is read a file, okay? Like Excel or CSV, okay? CSV. Let's understand how can we do that, okay? So you have seen that this is a um, file I have, Excel file I have already created. In this, I have 3 columns like this, right? I can close this file, and what I can do here is I can perhaps go here. I can go here, take this and put it outside where my Jupyter notebook is so that I can just give the file path here. Let me copy the file name here. Yep, I've taken the file name here. Now here, what I'm going to do here is data, okay, data 2 underscore df. So it's a new variable I'm creating. Now this time I'm not going to use data frame function. I don't want to convert my any data into data frame. This type I want to construct a data frame by reading the Excel. Okay. So here I'm going to write pandas dot read underscore Excel. Okay. So this is a readily available method or function you have, just like you have dot series, pandas dot series, and pandas dot data frame. Here you can see that it's pandas dot series, which is converting your existing data into the series. Here you have pandas dot data frame, which is converting your existing dictionary into data frame. And when you say pandas dot read Excel, then this is going to read the Excel, and whatever data is found in it, it is going to be converted into um, data frame. So here I'm going to provide the file here. Suppose the file is located at some other location. You're supposed to give the full path like this. Okay, something like this. Yeah. Now if I try to print here, now suppose someone else has given you the Excel file and you did not get the chance to open it. Perhaps you did not have the Excel. Then you can always read that Excel file in Pandas like this, and you can print what data it is. So you can see here that I got this data, right? Isn't it? Uh, Let me quickly remove this data frame um, headers, which is being constructed as, yeah, let me remove this shortly. Okay. Yep. Okay, good enough. So now let's do one thing. I want to set these as a different headers. So just like previous, I'm going to take a quick statistics look dot shape. Okay. And you can see here that it tells you there are 5 rows, 3 columns, isn't it? Same way you can get the other statistics. If I want to If I call this method, you'll get a quick statistics here. Okay. Now I can also get the columns here. Okay, you get these columns, right? Suppose you can, if you can get access the columns, then you can also update the column. So if I write here, okay, if I do like this, and thereafter if I try to print it here, and you can see that my columns got updated, right? So what the point is, this piece of syntax is helping you to access the columns. If you can access the columns of your data frame, then you can also update it. In a similar way, you can also update in case you forgot to create the um, row headers during its construction, or perhaps just because you are constructing your data frame by reading a file like this in which there is no chance of getting the row headers, then manually also you can set it. Okay, what I mean by manually, you can set it instead of columns, you can go for index attribute, and you can write here s1, s2, s5. All right, so this is how you can do. And thereafter, shortly, if you try to print it, data 2 underscore df, you will see that you have updated it, right? So this is all about creating the data frame from a different file and accessing it, its certain attributes. And also if you want to update it, you can update those attributes. Now, the next thing, like I said, since it's a data analytics using Pandas, you have to follow certain stages. First is get the input, okay, input data. So the input data, you can get it from the Python environment, or you can read some file, you can convert into data frame. Once you have done that, you might want to um, filter it, okay, filter the data. Now what, and then you might want to clean the data, okay, and once it's cleaned, you might want to process the data, okay, and once the processing is done, you might want to visualize it, and if need be, you might also want to output it. Okay, so these are the stages that we can give a quick sneak peek how all these stages can be achieved using Pandas. All right, so right now we just learned how to input the data. We can convert the existing data into the data frame, and we can also get the data from a file, right? Just like reading the Excel file. But if you if it's an Excel file, you can always put read Excel. If it's CSV file, you can read like underscore CSV, and then here it shall be CSV, provided that such kind of file exists. Okay, so you can read the, you can acquire the data from HTML, you can acquire data from XML, you can acquire the data from uh, database like SQL. You can also acquire from a direct web link, Excel file, CSV file. There are a lot of ways in which you can read that file or reach out to that channel and fetch the data and convert into data frame, so that you have a ready-made data frame like this. Now, now let's try to focus on what a filtering means in Pandas. So you have the data in this particular structure, and now you want to filter it out, right? So let's see how you can filter. You know that this variable is having my data frame, right? This is having my data frame. Now let's try to filter it. If I am printing here data 2 dot underscore df, and if I run this, you see complete data frame is given to me. But if I want only one column, then what I'm going to do is I'm going to put here just one column name like s underscore age, okay, student underscore age. So just like how in list you would put a square brackets and then you would put a position, in dictionary you would put the variable, and within the square bracket you would put a key. In a similar way, when it comes to filtering a data frame, it comes to slicing a data frame, in the you write the variable name which is containing the data frame, you put the square brackets, and you put the column name against which you want to filter out, right? So if I print it here, you can see that I got just one column here, right? Because I selected only one column. And remember that in Pandas, one column is called as series. Okay. So basically, data frame is a many series. It's a collection of many series, collection of many columns, right? So here you selected just one column and you got just age. But if you want to access many columns like s underscore name also, then remember that since this is happening to be a collection of data, that means obviously uh, if it's too many values, then you will have to encompass that or wrap it within a list, because that's what we do in Python. If it's a single entity, you just leave it like that. But if it's a collection of data, like a list of strings or list of numbers, you put it within a list, right? So within these outer square brackets, now this time I'm giving a collection of columns which I want to filter. So if I run this, you can see that two columns I have filtered, right? So this is one. Another way, what you can do is, suppose I want to filter only those whose age is greater than 30 or whose age is greater than or equal to 25. Only those content I want to filter out. Then what you can do is, I can just write age here, and within this I can write like this. So please observe the syntax carefully. I am writing data df. I have these square brackets. I have these within this I am writing like this. In age column, whatever is greater than or equal to 25, like this I can write. And if I run this, you can see that my data got filtered with respect to those rows only in which the column s underscore age is greater than or equal to 25, right? So this is like one of the ways of filtering the data. All right. Okay. Now, it's not always filtering like this. There is another way to filter your data. Okay. And that is called as dot lock or dot ilock methods. Okay. Let's try to learn how the lock works and how the ilock works. Okay. So here I can write data. Maybe I can write here filtered underscore data equal to, not data, it's data. Okay. Filter data equals to data to underscore df dot lock. So lock, you can say whether it's a lookup or it's locate or location, anything. Okay. But just like any object can have a method, I am this time utilizing the lock. I have put the square brackets here. Now remember, this is like a advanced way of filtering. Okay. So lock method is highly used in Pandas, and how it has to be used, please observe the syntax carefully. It is the data frame name dot lock and then square brackets. Remember, because you're filtering here and you're slicing here everywhere, whether it's a list or you use always the square brackets. Okay. So lock as in this lock square brackets, you are supposed to give hints with respect to rows and columns. Okay. What do you mean by rows? Suppose I want S1 row. Okay. Then I should provide S1, and in column, suppose I want city. So I can write S underscore city. So this is the hint that I'm giving to the pandas, to the lock method, that I want S1 row and S city. So shortly then, if I try to print here, filter data, and you will see that it's Delhi, right? So for S2, sorry, for S1, you can see that the city happens to be Delhi, right? However, if you want to see multiple rows, maybe S1 also you want to see, and you want to see S3 also. But like I said, this is becoming now a collection of data, right? So you are required to put it or encompass that within a square brackets. Okay. So you have put it a square brackets here right now, correct? So this is becoming a list of rows. So if I run this, you can see that for S1 it is Delhi, for S3 it is Tokyo. Now suppose not just one column, but you also have the preference to get many columns. Then I can also write here S underscore name. Okay. And you can put comma here, and these names also you can put in square brackets like this. And you can see that these rows got filtered and these columns got filtered, right? And you have the data here, isn't it? right? So this is one way. Another way could be you can also give the filtration with respect to ranges. So I can write here, starting at S1, okay, I want to go all the way up to S3, right? So this is like a range. I'm saying consider all the rows which starts at S1 and all the way up to S3. So S3 is excluded, but up to S2 you will be considering it. In a similar way, you know that your starting is S name, and I can say I want to start at S name and go all the way up to S city. So if I run this, you can see that, okay, this is considered. Now if I give S2 here, okay, this is getting filtered, isn't it? Um, this is another way. Suppose I do not give starting, then by default, starting row shall be considered like this. If I do not give ending row, then by default, end row will be considered. Okay. So basically, this ends up indicating that all the rows. Now look at this, correct? Similarly, if I say here, maybe if I can say here age, so you are going to start at age and go all the way up to city like this. Okay. But if I do not give city, then also it is going to go all the way up to city. And if I remove this also, then starting row, that is default, ending row, that is default, starting column, ending column, all this will be considered as a default, and you shall get the whole data frame, right? So this is one way to filter. Another thing that you should be remembering here is that on this filter data, you can always do the same thing. You know, if you want to see the shape, you can see that it is 5,3. I want to see the size. You can see that it is 15, right? So this is one of the ways. So that's all for this session. We have learned how to create data frames. We have learned how to create series. We have learned what a data frame is, what a series is. These are nothing but it's a tabular looking like a structure with row headers and row with column headers. And you can, Pandas gives you a good options to filter the data, to cleanse the data. So in the next session, we are going to learn how to filter the data further, and we are going to learn about the rest of the stages, like how to clean the data, how to process the data, and how to visualize data, and how to output it. So if you want to create another, if you want to output your filtered conditions, and you want to output your uh, the filtered and processed data frame into a Excel file or a CSV file, that is also we're going to cover shortly in the next video, right? Okay, thank you.